Start now. So you can register by visiting this link. It's very simple. Just adding your email, personal details and mobile number, pin code, address, normal address basically, but like city Pune, and then you can register. You will get the confirmation email for this 11 July. Just make sure after attending this session, 3 hour session, 11 July means I think Sunday is coming. Acha no, 11 no, 11 July. It's a Thursday. So after attending this session, you have to give the feedback. Otherwise, you will not get that $50 credit. So once you submit the feedback form as a survey, then you will get the credit after a couple of days. So that it will be helps to utilize. So now coming to the main point, let me draw here. Okay, normally we have two options when we write down the Terraform folder structure, right? When we initially start with this, like either we can write down everything in the main.tf file. There is no basically restrict to manner like you can use folder structure. Why we need to use that module base or folder structure? I will give you the reason. Okay. In earlier session we have seen, right? We have created VPC, your EC2 instance, and your RDS like that. So you can use this all the resources created by using main.tf file as well. So you don't need to write down the separate files. Okay. The reason behind to use separate files like a module based like we normally say in the real time. So we can write down the VPC for the separate file, then your EC2, then your RDS. Okay. Then let's say tomorrow you are going to create the EKS cluster, EKS. Then it might become more requirement like S3 bucket or your IMA roles, something. Okay. Like that. The reason behind this basically, so if you write down all the code in the single file, main.tf file, so when you do the troubleshooting for any kind of resources in a real time, so you need to debug all the code unnecessary because there might be 100 line of codes. Okay, so it will a little bit time consuming process. You can't sure like which line or any it's take a little bit more time basically to troubleshoot the things in the if you have written all the codes in the single file. Okay, so that is the reason people are normally used in the real time base module wise. Module wise means what is the meaning of module wise? Basically the folder structure. So let's say you are creating the VPC. So you can create separate VPC folder. In that VPC folder, you can add your subnets, configuration, your like obviously variables file will be there. Then your other stuffs like VPC CIDR providers like that. Okay. Same thing for your EC2 instance. Same thing for RDS, EKS, S3. Okay. So in case tomorrow, if you get any issues related to let's say key EC2 instance, so you cannot go and find out the each files like a main dot like for example main dot files. Okay, you don't need to debug each code here. You can simply go to straightforward to this specific file like EC2 and you can just debug that code. So that will be easy to understand and easy to identify. Okay, even if let's say you tomorrow you will leave that organization, if someone getting hired, right? So he can easily understand the with the by the helping of folder structure. So he don't need to refer all the main.tf file just to understand the each code. He can simply go to the folder structure segregated and he can easily understand the configuration, right? So that is the things like mostly people use real-time folder structure. So also we have seen this project last time, right? So if you look at this folder structure or we can call it as a module wise. So let's say this is the VPC, okay? If you don't want to keep this folder structure, you can definitely go with this main.tf file, single file. You don't need to maintain this backend.tf, output.tf, providers, subnets, terraform.tf vars or variable.tf. Okay. So you can simply add all the information in the main.tf files and you can just create the infrastructure. That also option we have. But as I said, in the real time industry, people use module wise because it will be easy to understand. Okay. So now if I want to understand the code of this Terraform, right? So it will easily help me to understand like, yeah, this is the code for the EKS cluster dedicatedly, and this code is for the VPC. Okay. So it will easily help me to understand the codes for the Terraform folders code basically. So when we look at this file now, is that clear? Like why we use folder structure instead of the main.tf file in the real time, or any doubts?
Yes, it is clear.
Yes, clear.
Okay. So now coming to this file structure like backend.tf, main.tf, output.tf, providers.pf, like tf subnets, tf vars. Okay. So in that case, here in main.tf file, we can easily write down all the folder file structure inside that. Like if you want output.tf, so we don't need to write down the separate output.tf or providers.tf. Okay, we can maintain all the information in single file as well. So normally we write down here. Okay, if I show you the earlier project, let me open that, which we have covered initially in the main.tf file. So in that case,
Hello.
I think त्यांचं नेट गेलंय.
बहुतेक Android system.
hello, I'm audible.
Yes, sir, you are audible.
Yeah, sorry, the power failure is here.
Okay.
Anyways, so initially we learned this, right? Demo DevOps EC2. If I open this, let me quickly check from here. Okay. See, in this state, we have only single file main.tf. So what we have done is we have added providers, right? Then your data block here related to VPC, your subnet, your SSL certificate, right? All the blocks we have mentioned like EC2 instance. Then your these are the resources block for the load balancer. And there is one more output block. I want to show you that. Where is that output? I think that's not in this. Okay, I will show you another project where you can see the example of we can maintain all the file structure inside the main.tf file. Okay, and let me show you one more, that output.tf file structure. I think in this might be. Let me check. Resource. Yeah, you can see here output block. Okay, so why we use output block? So let's say you are deploying something by using Terraform and you don't have AWS account access, or you want support some particular reason. So in that case, output.tf file, what will happen, or output block. So when you deploy any resources by using Terraform, so once that resource get created inside the AWS accounts, he will automatically fetch the resource ID, like your subnet ID, subnet values, or let's say you are writing down the block for the load balancer, for example. So we know load balancer will generate the one endpoint URL, right, which is a DNS endpoint. So we don't need to go to the AWS account and check that URL. Okay. So instead of that, we can simply just write down the output block here inside the configuration file, and we can get those values. So the benefit like is we don't need to separately log into that AWS accounts, okay, and fetch those details. We can directly write down the output block as simple as, and we can get those information like your VPC ID, your subnet ID, then your load balancer ID, like endpoint like that. Even you can write down the output block for your elastic IP address as well. Let's say you are creating the EC2 instance, right? So after creating the EC2 instance, what we will get? We will get the IP address, which is the public IP address. So we can write down the output block for that as well. So once the resource get deployed properly, we will get the elastic IP address. So that is the use case of the output block. So you can see this simple format, like we can definitely mention this all the blocks in single file as well. But why we are maintaining separate files? I will come to that. Which module wise we want to see. Okay. So this is, as I said earlier, this is the based on the real-time project we have created. Okay. So here instead of
Namdev,
maintaining, yeah,
Namdev, there is a Terraform.tf vars files is there, or variable files
yeah,
.tf files is there.
I will
TF
come to
var
that.
files.
Sorry.
Okay, not an issue.
Yeah, I will come to that, but don't worry, because last time you had question doubt on that. Now you not understand properly, so I will come to that. So now, so normally you can see the backend.tf file. So this is as simple as this is the state file. State file means what? Whatever the changes you are deploying to the target service, which is your provider like AWS, Azure, or GCP. So all the information will store in the state file. State file, okay. So that is the reason we use state file here. If you don't specify backend.tf file by default, Terraform will consider as a local state file. So he can generate Terraform.state file, on the local, and that format will be like a TF state file. So if you unless you specify something like S3 backend, which supported by the Terraform, so he will generate the state file on the remote location where you provided the S3 bucket URL, okay, like this backend.tf, and we have given this S3 bucket name. Then that is the folder structure inside that S3 bucket. It will create automatically. Then you have passing the region, okay. This is the supported format of the Terraform. So instead of storing the state file on your local machine, okay, because let's say you are storing the state file on your local machine and you are working on the real time. So in your team case, there might be multiple developers or DevOps engineer. If you are storing state file on your local machine and another people are trying to deploy something, so your both state file will not be sync, right? So in that case, what will happen? Whatever the state file available in that your another developer or DevOps, so he can deploy on based on that changes. What are the state file there? Okay, to avoid
Namdev, can you
over
repeat
it,
this?
let me draw here. Let's say you have two DevOps engineer, for example, okay, and you are creating EC2 instance as a developer one, and this is the your colleague developer two. He is creating the RDS. So by default, if you don't specify S3 backend as a state remote state, what will happen? Terraform will generate the state file locally on your local machine, whatever if you are using desktop, laptop, something. Okay, you have deployed properly EC2 instance on the AWS account, for example. But this desired state available on your state machine only, your local. But the with your colleague, which you are he is trying to deploy the RDS. In his case, his state file, he don't have information about the EC2 instance, right? So in that case, he will only deploy the your RDS information. So in that case, your resource will be mismatched or it might be delayed specifically because state file are different. So how Terraform will understand how he will maintain this all the desired state, like you whatever the changes you are doing. So there might be chances like resource deletion because both files are mismatching as a state maintaining, right? So and the other case might be if something goes wrong with your local system or corrupted the state file. So that also be a very risky point here. So to avoid this kind of situation, even no one suggests to use state file to storing in the GitLab as well, like CI/CD pipeline. So as a best practice, we can use S3 backend. For example, AWS. Okay, for Azure, I think it's a blob storage or something they call as a S3 bucket, right? The naming format is different in the Azure or GCP. So as a best practice, we should use a S3 as a backend where we can store the state file. So he will maintain the all the desired state. Whatever the changes you are doing, he will maintain his all the changes history. So that is the reason we have given the specifically here backend.tf. So when Terraform trying to deploy, so he will check this naming format file and he will just refer to that backend. So instead of storing the state file on the local machine, he can directly store the on the remotely. You can see there is no state file locally available. Okay. If I open another project, so I can show you this. Earlier we have learned this, right? A simple EC2 instance. You can see state file was generated locally. This is the state file, TF state. Okay. Because here in this folder structure, we have not mentioned that backend.tf where the remote state. Okay. And this is your main.tf file. He will fetch your all module and just refer and just deploy the resources, whatever you have mentioned here. Now output.tf. So as I shown, we have earlier mentioned in the main.tf file, whatever output value we required, we have given the output block in that main.tf file. But now the difference is only we have segregated properly with the structure manner. So instead of increasing the main.tf folder uh, line here, coding line, so we can just segregate it properly. So we can easily understand like, yes, we are just getting this value like VPC ID, your internet gateway ID, public route table ID, then your subnet ID. You can also add for the load balancer as well if you are deploying the load balancer here. Okay. And this value you can refer as a main.tf file like this resource block, AWS route table, then your resource block name. So whenever we deploy these resources, it will automatically generate the output based on whatever the output block we have mentioned here. So in this project, we will get the output. I will show you that how once we deploy this, how output will be shown on the prompt. Just don't try to output as a sensitive information like secret manager value or something. Only basic information like load balancer endpoint, elastic IP address, S3 bucket name, S3 bucket ARN like that only. Okay. Now providers.tf like these are the only information like plugins information, which version minimum we want to use or more than that. And this is the provider for the AWS region. Basically, you are in which region you want to deploy the resources. Let's say you are deploying in the North Virginia or Mumbai or Hyderabad or any other region, Singapore like that. So you can pass here. So I will come to that, these configuration files where this region he will fetch because we have not hard coded here. Where dot region we are using as a variables here. Okay. This is the subnet configuration for the VPC. Now the main thing is like why we use tf vars or variable.tf. So in this case, let me tf vars and tf. This was the main concern, right? Why we use two files.
Yes.
Terraform.tf vars and variable.tf. Okay. So what is the use case of these two files? Tf vars variables. So there is no like restriction to use this tf vars. Okay. Even we can just delete this file in the project, and we can use only the single file like variable.tf. Okay. So in the variable.tf file, I will show you practically so you can understand. Let me open that variable and tf first. Okay. So you are deploying VPC, your subnets, public subnet, private subnet, right? So if you don't want to use TFOR files, absolutely fine. In the variable.tf file, you should give the all the values like whatever the region you are using, you can consider line of region equal to US East 1, which is the North Virginia region code. Okay. So this value is passing where in the providers region equal to variables dot region. So he will getting the region variables from the variable.tf file. So now variable.tf file, if you don't want to use TFVARs, okay, you can even use variable.tf file where you can add the all the required values for the VPC. Let's say you are creating the VPC, you can pass the VPC CIDR here. Okay, your tags, your VPC name, your subnet zone, then CIDR range like a public and private. Okay, these if you don't want to use TFVARs. Okay, when you use TFVARs files, okay, then in the TF4 files, you don't need to write down all the values like this kind of naming convention. You can only use the values here like VPC CIDR range, tag name for the VPC, then your VPC name and range of the public subnet, private subnet, for example. Okay, public subnet zone, then your public subnet CIDR range. So how you can call this TF4s into the variable files? You can see here I will show you the meaning of this file. So by default, as we have seen earlier, if you don't want to use TFRs files, so in that case, we need to pass the exact value in this variable.tf file. Okay. Now still you are able to see this default value, right? That might get you the confused like value is already there. Then why we are using the TFRs files? Okay. The reason is this: if you missed or don't specify any values in this file structure, then we are telling this Terraform folder variable.tf files. If we don't have any values in this tfrs files, then consider as a default value is here. If you don't find any values in the terraform.tfvars files, then he need to consider by default value should be this one, whatever the range we have given. This is for the VPC CID area range, then VPC name for the public subnet zone. If this file variable.tf file don't find any values related to public subnet zone inside the tf-var files, then consider default value is this one. Same thing for public CIDR range, for private subnet zone and for private subnet CIDR. That is the use case of the tf-var files. Okay. You can use variable.tf file instead of tf-var files, but if you want to specify, let's say you are working in the lengthy project, in that case, we will pass lengthy values here like for the all the different structure like VPC and other ADS, secret manager or other services. So the variable.tf file, what will happen if he don't file, let's say I just comment this like this. Okay. So what will happen? Variable.tf file will look at this configuration terraform.tfvars. So what is the VPC CIDR range mentioned in this file? So what is the CIDR range mentioned? VPC underscore CIDR range 10.000/16. So what will happen? Variable.tf file consider as that range because that value is mentioned in tf-var files. Okay. And if we enable this, so what will happen? Variable.tf file will try to look at the tf-var files. Let's say this one. If you don't specify this somehow mistakenly or unknowingly, so what will happen? Variable.tf file will consider as this default value. Is that clear or should I explain again? Any confusion or not understanding?
थोड़ा सा confusion लग रहा है. Because thing
Okay,
is
let
that
me.
I'll be repeating that, right?
Mhm,
Terraform dot uh, Terraform dot TF files and Terraform variable dot TF files. Both the
mhm.
files are the same. Okay, but for the bigger project, both the files are required. For the smaller projects, uh, variable.tf file is enough, not required the terraform.tf files.
Yeah,
And
even for
situation,
small
the
project as
situation is
well.
just the
Mhm,
situation is that like in the variable.tf files, whatever your segregation is there, the
mhm.
segregation is properly available in the variable.tf files.
Yes.
But in variable files, the segregation is not properly. The
Yeah,
multiple things are there with the single things. But
yeah. Mhm.
as per the environment requirement, terraform.tf.var files is required.
Yeah, if you are using even for the small project also you can use this folder structure. So as I said, we are going to structureize each thing separately here. As we have seen earlier, like, we have given all the information in the main.tf file, output, your providers, your subnet, like that. So instead of that, because real time people use a segregated manner, so that is the reason we have just separated each things, like your output.tf, your providers.tf, backend.tf, like this. Tf was only uh, we store as a value there, variable value. As you can see, it's a straightforward file, public subnet zone and the value, public CIDR range and their value, right? Like this. And we can call this values in the variable.tf file. When actual process happens, deployment started now, variable.tf file will consider its this first VPC CIDR. If he don't find this CIDR range in the TFR files, so he will by default consider as the default value. If you don't find this VPC CIDR range in the TFR files, this is the working of this Terraform when we try to deploy. So what will happen? We can try two way to check the demo. One thing we can just deploy as it is. Okay. Then second time we will try to disable these values and we will see. Right? Is that okay for to check this clear?
Yes, for me, okay. Rohit, if you have any doubt, you just ask here.
No, no, I'm clear.
Okay. So let me. So first you should make sure like you are in the proper folder structure, a directory. I am not in the that. Otherwise, that will give the error. Let me list out. We need to go to that Terraform, then VPC, and now I can run the Terraform initialization. TFRs value we हम बस value store करने के लिए यूज होते हैं वहां पे. बाकी variables dot files initialize completed. Let me plan it. अगर कोई वैल्यू बाय डिफॉल्ट वेरिएबल डॉट फाइल जब एग्जीक्यूट होती है ना ड्यूरिंग द डिप्लॉयमेंट्स, वो जस्ट चेक करेगा कि ये वैल्यू वहां उसको मिलता है कि नहीं, कहाँ पे TF वार्स में. अगर वो वैल्यू वहां पे नहीं मिलता है उसको, देन ही विल गो एज अ डिफॉल्ट वैल्यू, दिस वन. दैट इज द वर्किंग रिलेशन बिटवीन दिस टू फाइल्स. ये हम सेपरेटली स्ट्रक्चर बना रहे हैं इसलिए वो इतना सब फाइल स्ट्रक्चर बन रहा है. अदरवाइज as you seen in the main.tf file, we can mention everything in the single file. But when we consider as a real time cases, now we will not use that standard like everything will be in the main.tf file. That will not a case. There is a proper folder structure as you are able to see here. Backend, main.tf, providers like this. कोई डेवलपर तो इतने एक्सपर्ट रहते हैं इसमें कि अलग अलग फोल्डर स्ट्रक्चर बना के उसको अलग अलग तरीके से कॉल करते हैं। द पर्सन हु हैज मोर एक्सपर्टीज। ऐसे भी प्रोजेक्ट देखे हैं मैंने रियल टाइम। क्योंकि एक ही फाइल में अगर हम सब कुछ रखेंगे ना तो दैट माइट बी अ वेरी लेंथी प्रोसेस टू ट्रबल शूट एनीथिंग, एंड दैट्स how it works in real time. So we need to segregate each things separately. Even we are using in the CDK right now. So we are for structurized properly. Like we are not keeping everything in the single file, single stack file. We are separating for, let's say for VPC, we are separating it. Then your RDS, your case cluster, or your IMS service, or Lambda function. We are separating each thing separate file in the CDK, because that will helps to troubleshoot very quickly. If something issue related to your subnet RDS or any IMA policies or any Lambda functions, we don't need to read each line in the main.tf file. We can quickly jump into the that particular folder, and we can see which variables are missing or any format not properly set up like that. That will help actually, because in the real time case we need to deal with the multiple services. Let me go and check this VPC status. As of now, it's a default one VPC. Let me refresh it. This is the POC VPC which we are creating. See, so we have written the output.tf, right? Output block. So what we have passed, your VPC ID, your internet gateway ID, public route table, and what we are calling as output dot ID, right? So we will get the IDs there. So you can see the resources has been. Okay, any disturbance in voice?
Yes.
Let me switch. Power is restored now. Okay, now it's fine.
Yes, it's
Yes.
fine now.
Okay. You can see here output, whatever we have given in the output block. Internet gateway ID, we will get this internet gateway ID, then your route table ID, private subnets. So we have passed the three subnet there, right? Three private subnet, three public subnet. So you can see the subnet IDs. Okay. If you want to verify this, let's go to verify this VPC ID. So for this, the benefit is like we don't need to go to the AWS accounts and check this output or VPC ID. We can directly get it. Let me verify that. See, also if you want to verify the subnets, we can verify any one like VPC public subnet 1A 538. Okay. Public 1 538 first wala. Right. So this is the benefit of this structurizing and using different blocks. So that will be helpful. Now what will happen? We can just destroy it. Okay. And we want to try from the different way. Okay. Sorry, not CDK. Terraform destroy. Chico, एक minute. Huh?
I have one question here, sir.
Yes, yes.
If we have multiple folders and we run command as a Terraform destroy, so there is in destroying all folders or in only single folder.
So wherever you are using that workspace, na, only that, because we are executing inside the VPC workspace, right? So only that values will be impacted. So it's destroyed. So what we will do is, let me try to delete this TFVARS files. Okay. So now we don't have TFVARS files. So what will happen? Variable dot files will try to look at this TFVARS, but he will not find, and he can just check this default value. We will try to see this if it gives any error or not. Let me try to run this Terraform plan. And we can use apply now. Okay, it's showing properly. If you don't want to use that, yes, we can add the auto flag, auto approve. Okay, so that parameter we can pass in the CI/CD pipeline. And we can see now. Our earlier VPC ID was 4426, but now this time it created different one, right? DE90, and you can see the CID range 10./16. Okay, I hope it's makes sense now. The difference between variables or tf.var files, or still any other doubts?
No, now it is clear.
Okay, so I just found one link where this module wise folder structure definition mentioned. So let me try to share that. Okay, standard module structure where can just read little bit about the root modules, readme files, your main.tf variables.fields output, like that. So you definitely can just go through this folder structure. It will help more to understand this. So it has been created. So this is just a configuration of this. Now we can just step back, okay, to the proper folder structure, which is the AKS, right? So in this case, this is the configuration file for the EKS cluster, not the VPC. Okay, because we have, when we try to, as we have seen manually, we required VPC to set up the EKS cluster. Okay, otherwise that will be without VPC not possible. So in that case, first we have created the VPC. Okay, then VPC things we have passes here. This is the backend file where state file will store. Okay, let me show you that S3 bucket as well. S3 bucket. And this is the Terraform file. he will create two folder, VPC and EKS. Why he created two folder? Because we have given the path like this. Let's say for EKS cluster, we have given the backend.tf file. Path is like EKS, then EKS cluster state file. Okay. But in the VPC, what we have given VPC slash and the VPC state file, right? So both will maintain separately because both are the separate things, VPC and EKS cluster. So that is the reason we have given this two folder structure here, this file. And we have seen the manually like how we can create the EKS cluster. We required IMA role, then your certificate. This is the permission. And this is the same thing like folder structure we have maintained separately. So we have not written the separate file, main single file like main.tf. Okay, you can see this configuration like VPC node file, then VPC, sorry, EKS cluster configuration, which on demand capacity by default, then T2 medium. This is the instance type. We can just add this configuration file, scaling minimum, maximum, and desired value. Then this is the policy, which because when we seen the manual configuration of the EKS cluster, we learned that right. We require the that IAM role we have seen last time, right? If you remember. So this is just a provider's configuration where we are using the region, and this is the variable configuration where we have just passed in only the US region name, EKS cluster version, and the EKS name only. So if you want to deploy this, same thing we can just follow. Any doubts, folder structure, or it's clear now?
Now there is one doubt is there. For example, if I want to first create the S3 bucket, after that I need to create the.
Yes, yes. For
So how?
as simple as first, the first priority is like you can just manually you can just create the S3 bucket in the AWS account. Okay, that S3 bucket you can just pass here in the backend.tf file.
We can set the priority.
Priority means this is the way basically before the deployment when we are going to deploy any project. So first we need to create the S3 bucket in AWS account access. If you don't have AWS account access, so definitely we can ask the platform team who has the AWS account access or whatever the process is there, like raising the Jira ticket or something. But in real time cases, you will not face this issue because it's already stable there. Like someone already created this setup. If you get this opportunity to set up from the scratch, then and if you have a AWS account access to create the S3 bucket, then definitely we can just go ahead and create whatever the naming convention you follow for the S3 bucket. This is just a demo one, so I just added like this demo DevOps something. But in your case, you can just add a naming convention like your project and whatever you follow basically there. And then second task will be like your first, then create the VPC. Okay, because the EKS cluster will require the VPC, and then you can just create the EKS cluster. If you get the opportunity to work on the real time from the scratch, otherwise everything will be you will get ready made there. You have to just manage the any changes related to pipeline, related to any configuration like that. So after initialization, we can just try to run this plan command. So we can just identify like what's going on for the deployment, and then you can just apply this. I want to show you one more thing because I had done that troubleshooting yesterday. Let me try to add yes here. Okay, so he will start creating the EKS cluster. Let me quickly go to this EKS service and check. As you can see the Kubernetes version and it's going to create, okay, POC case, which we have given the name. So yesterday I was trying like this. I want to store this backend.tf. I mean the state file on the locally. So I just try to remove this backend.tf file. This is not recommended for the real time. Okay, I was just practicing that. So in that case, he will give the error when we try to run the Terraform init command. Okay, this is just a of the context practice. So I was just trying so randomly. So in that case, you need to reconfigure that state file. Let's say Terraform space init. Then you have to pass the parameter like hyphen reconfigure. Okay. So he will reset the your state file and he will instead of creating the state file and generating for the S3 bucket, he will maintain in the local file, local system here only. But the additional parameter you have to pass like hyphen reconfigure option there. He will take he will take the couple of minutes because it's a case cluster creation time now. It might take 5 to 10 minutes. So I think that's all for the today's session. And definitely tomorrow we will cover more on that Kubernetes architecture and different stuffs going forward. YAML file and whatever the things are available in the real-time cases. And we can try to deploy the pods because I want to show you this project as well. As of now, we just created the VPC. We are just creating the EKS cluster. Now, what about the applications? Okay. So I just prepared this YAML file for the Helm chart. Okay. So I will show you that as well. So where different file is available, namespace, PVC, secrets like that. Okay. So I will explain this in detail tomorrow. So before conclude, any doubts for today in the Terraform? Anyone tried on their local machine?
For
Like
example, for example, if our laptop we are running from the Terraform codes. Okay. Meanwhile, my laptop is getting blue dump error. It will be given. So, what is the impact for that? Whatever the
uh,
code is halfly
mhm.
running, on that basis, it will be running fully or what? It will be stuck.
So you are saying like you are just executing this command, right?
Yes,
And your system get any corruption or something.
corruption is there.
In the pipeline, if you trigger the pipeline, so and once you even you lock your laptop or something, so that will not impact when we trying from the pipeline. We have seen this in the real time in project. Okay. Once you trigger the pipeline and you can just lock your laptop, it will absolutely fine. But in the local case, might be you are just running from your local system, right? This process. If I try to shut down that process, so might be interrupt that, right? Or let's say this process is going on, so let me try to kill it. So what will happen? You can see stopping operation, interrupts received. Please wait for the Terraform to exit or data loss may occur. Gracefully shutting down. Execution failed, halted. Waiting for the EKS cluster, create context, cancelled. Okay. And you can see with the EKS cluster, one line resource failed basically. So let's go and verify this. What will happen? This might be a general question. Okay, but in the real-time cases, we will deploy everything from the pipeline, not from our local machine. So we can see now we have just interrupted this execution, but still the creation is going on. So we might need to wait couple of minutes and we will see the status, what will happen. Okay, after a couple of minutes, I will check the status. Will that create or it's a fail? Okay.
Okay.
Any other questions or doubts?